Hello. Today we are going to talk about how link fault signaling happens on a 100 gig link or even on a 400 gig link. So, link fault signaling is a key attribute used in signaling the direction of fault that happens on a given 100 gig link. On the diagram on the screen, I have two devices. One is a Juniper box that is connected to an Ixia. Now you can see that the Juniper box interface is ET002 and the Ixia device is port number 4. This is a 100 gig connection. It is a single fiber. So within the fiber, you obviously have a TX RX pair from left to right, and likewise there is another TX RX pair from right towards left. So that is what is being demonstrated on the diagram, but logically or technically it is still a single fiber. Now, if you have a link failure that happens from the TX direction of the MX towards the RX direction of the Ixia, in other words, if you were to turn off the laser or set interface disable on the Juniper, what really happens is the lasers are turned off and the RX is seeing a interruption of a light signal. The moment it sees that there is an interruption of light signal, the RX will record a local fault. That is how they identify the direction of fault. Once it records the local fault, the TX will send remote fault notification to the MX304. So telling the MX that the direction of failure is somewhere between the TX and RX of the path. So the moment you see a remote fault, it actually does not indicate that the fault is really on the far end. It only indicates that the fault is between the TX and the RX. So the fact that Ixia is recording a local fault only signifies that it has had an interruption in the light from the TX to RX pair. Now we will demonstrate this kind of scenario on the setup. I have a Juniper router interface as per the diagram, which is ET002, that is connected to the Ixia. As you can see, it's a 100 gig interface, and at the moment there are no active alarms. Now let me try to simulate a failure from the Ixia itself to begin with, wherein I'm going to stop the laser on the Ixia's TX and we will see what happens. So quickly going to the Ixia. So on the Ixia screen, how do you create a link flap scenario? First thing, you click the port that you are trying to flap. Once you click on the port, you will see that it will identify the slot and where the port is. And for that port, in my case, the port number is 4 as per the diagram here, port number 4 on the Ixia. You see there is a value called L1 lag settings. When you click on it, you have to then choose all ports. It will identify the port that is a part of this Ixia session. In my case, it is port number 4. You can see here, port number 4. And there are a couple of options to turn off or flap the link. One option is if you click on actions, you have something called as simulate port link up and link down. Pretty much has the same effect as turning off the laser. But in this example, I will just simply turn off the laser. So before turning off the laser, the key part is now you're shutting off the laser on the TX of the Ixia. The RX on the MX is going to see a live disruption, and hence in this case what will happen is the faults will flip. So here you will have a local fault recorded by the MX and the Ixia will actually be sent a remote fault because this failure now happens at the TX of the TX to RX direction. So I'll just demonstrate that in an easier way. Let me do that by just duplicating this diagram. So I will rename this as Ixia TX failure. And this one will be renamed as Juniper TX failure. Now on the Ixia TX failure, I'll just take this flapped second. So let me first bring the local fault remote fault because the failures are not in this direction. So this is the direction of failure because I'm going to fail the Ixia's TX. So that's the failure direction. This is the direction of remote fault notification. Just bringing the failure link to this direction to demonstrate where the failure is. Okay, so this is what I'm going to simulate first, and then we will simulate a Juniper failure as well. So the first fail scenario is Ixia is going to have a laser cut, and then you will see what Juniper really records in terms of direction of fault and what Ixia will see. So quickly going into the Ixia, I'm going to turn off the laser. Before I turn off the laser, you know the status of the interface is up. There is no active alarms. So when I quickly turn off the laser, now if I check on the interface, you see it is first thing is down, and you can very clearly say it is saying local fault. That's because the TX to RX has failed and the RX will record it as a local fault, which is what it is recording on the Juniper. And also in the log messages, it will clearly say MAC local fault is set. MAC remote fault is 0 because the MX is recording a MAC local fault, and it will send a remote fault to the far end. That is what is happening here. Now when you bring back the link on the Ixia by just turning back the laser on, if you check again, the link is up, the alarms have cleared, and also you can see the MAC local fault is now reset back to 0. So this is how the link fault signaling happens as per this diagram. Now doing the same setup or failure through the Juniper point of view. So how does it work? Now if I go to the Juniper interface and I do set interface ET002 disable, before I'm committing it, I'm checking the interface. You can see it is up, no active alarms. Now when I commit it, what I expect is, because you've turned off the TX, Ixia will record a local fault and Juniper should show remote fault. Now when I check on the interface of the Juniper, you can see the link is down and Juniper interface is recording a remote fault. That's because the Ixia had transmitted or identified that it is a local fault recorded on the Ixia, and then it is sending out a remote fault. So that's what you see here. And the logs will also be correspondingly set to show you where the remote fault or local fault is happening. Hope you find this useful in terms of how link fault signaling happens when you see a local fault and when you see a remote fault. Bye for now.